2004, question 4b. It's a wedge question. And the first thing we're asked is to draw separate diagrams for the wedge and the particle. So we'll draw the diagram for the particle first. We'll show the wedge in the background. And the particle. And now the forces on the particle. There's always a weight acting downwards, that's mg. The particle has a mass of 3 kilograms, which means gravity must be 3g downwards. And also there's a reaction force from the wedge, perpendicular to the surface. We'll call that R. And that's it. It's a smooth surface, so there is no friction force, so the only forces are the reaction force and the weight 3g downwards. Next thing you should always do is show your x and y axis. So, and the easiest thing to do is to pick the x axis along the direction of motion, which is down the plane as shown, and pick the y axis perpendicular to that. Now we're told that this angle here is 45 degrees, which means this angle here is the same. And now we must resolve the weight parallel to x and y, because R is already along y. So let's do that over here. Always do your resolving away from the main diagram, because otherwise it could be interpreted as extra forces instead of component forces. And the weight downwards is 3g, and we can resolve by having a component parallel to the y-axis above and parallel to the x-axis. And the angle in here is still 45, which means this is 3g cos 45, or 3g over root 2, and this is 3g sin 45, also 3g over root 2. Next we must show the accelerations on the system, and there are 2 accelerations we have to consider. First, and to emphasize that they're accelerations and not forces, not to get mixed up with forces, we'll do them in a different colour for the moment. So there's an acceleration of the object itself, 3 kg, we'll call that A. So it's accelerating down the plane with acceleration A. But not only that, the wedge underneath it is accelerating to the right with an acceleration F. And at this stage you should bring those two together on an acceleration diagram. We show it over here. So we've got A along the x direction, and F is horizontal. And we should resolve F parallel to our new x-axis and our new y-axis. So here's the component parallel to x, and there's the component parallel to y. And again, don't forget the arrows, these are very important for applying the F equals ma equation later. Now because all the angles are 45, this is going to be F over root 2, F cos 45, and F sin 45, F over root 2 yet again. And that's the force and acceleration diagram for the 3 kg. Now we have to do the same thing for the wedge. We've got to draw the wedge again, but this time we're considering the forces on the wedge from outside. So let's just draw the wedge here. There's the object. And this time the force is on the wedge. Well, the wedge is on horizontal ground. And the first force we always put in is the weight, of course. It's going to have a weight downwards of 4g because its mass is 4. It's 4g downwards. And because it's on the ground, it's going to have a reaction force upwards from the ground, which we'll call S. And the angle here again is 45. And one last force on the wedge, and this force arises because of Newton's third law. If we go back to the first diagram, we'll see that the wedge pushes the 3 kg with a reaction force R. Therefore, because of Newton's third law, the 3 kg pushes back with an equal and opposite force R. So there's a force R pushing into the wedge like this from the particle. And now we can resolve R along the horizontal. We can pick it the horizontal as our new x-axis. Just tidy this up here. So make this our new x-axis this time because the wedge is moving in that horizontal direction. This means we must resolve all forces along our new x or y axis. There's R, and because the angle is 45, this must be R over root 2, or that's R cos 45 and R sin 45, R over root 2 again. And acceleration, there's only one acceleration here, and that's F, the acceleration of the wedge itself. And that, of course, is F. That's part out the question. Done the force diagrams for the wedge and for the 3 kg particle.